Good evening, everybody. It's Monday night, my friends, and in lieu of actually playing a game tonight, I just kind of wasn't really in the mood to play any game tonight. And honestly, I did skip Saturday's stream because I was just completely in the zone, friends. I was just like focused up, and I was like, you know what? I was a little bit tired. I was like, you know what? I just want to let me just focus up and just do this, and just focus on this. And it went well, my friends, to say the least. But welcome on in, everybody. Welcome. Hope everyone is doing well. Hope you're all healthy and happy and all those things. Kicking butt, taking names, getting things done, and enjoying life along the way. So, what have I done? What have I done? Last time we were here, yeah, I was just looking at here, chapter 13 finished 3 days ago. So, when we were last together on the live stream, we got through all of chapter 13, which was just audio stuff. And then I mentioned that chapter 14 and 15 were going to be biggins because they were dealing with deferred rendering, deferred shading, and all the changes for that. And then chapter 15 was the second part of all that, where you're doing physicality-based rendering and material changes and all that stuff. Turns out, chapter 14 was a bit of a snooze fest. There were changes here, certainly, but it wasn't like an earth-shattering kaboom. Even though it kind of looks like there's a lot there, it really didn't change much. Chapter 15, however, is where the rubber really hits the road as far as this deferred rendering is concerned, and this is where we actually start to process the 3D model files differently. We actually pull in particular, normals and tangents and bitangents, and I'm sure, well, I know what a normal is. I'm sure tangent and bitangent will mean something to me eventually. So a lot of it was around that, reading that in, making it available to the shaders, and then there was a literal crap ton of changes to the shaders, and I did not copy paste them. I actually sat down and typed them out, even though they were using the shaders the shaders in the book example are sourced from the internet, so they are like, I think they're MIT licensed stuff, and I'm open sourcing this engine, so I should be good to go there with all that. Even then, I still typed it all out. It's mostly the same. There's a few little changes here and there to like names of things, but you can see like a crap ton of. This is just a small piece of it. It's hundreds of lines. It feels like hundreds of lines. It may not be hundreds of lines, but it feels like it. But at the end of the day, we have a lighting renderer now in the pipeline, and well, I guess I can just show you where we're at. This is hard to see here because this is a static image, but if I pop on over to what we've got going here now, I've spent the better part of today off camera getting this to work, because as usual I did all the changes, and I was getting just absolute mom spaghetti. Like literally everything was just like, nothing looked right on the screen. It looked like just a jumble of line segments that were textured and stuff. It was very crazy looking. But it's once I figured out the problem, and I kind of suspected I knew what the problem was, but I had to kind of work my way to it. What happened was, so in the book's code, they convert the object files. They pull the data out of the object model files, and they write the vertex information and all this new information, the tangents and normals and all that stuff, out to they serialize it out to a binary file. And of course I bitched and moaned about it because it's like, well, you're already reading JSON files. Why not throw it all out into JSON files? And so I did the sensible thing and threw them all into all the vertices and everything into a JSON file. And I dutifully did that again with the with these new things. However, one of the gotchas of like looking at what how the book's code has changed from one chapter to the next is that because they were reading those values in as binary, they didn't have to make any changes to how they read those in. Namely in their, I believe they have a, let's see if I can find it. It's create vertices buffers. I gotta find the right chapter for it because this search is a pain in my butt here. Yeah. So is it this one? Looking at the right one. I think this is, yes. I think this is the one. Yeah. See, this takes a data input stream, which is basically the serialized file, the binary file. It takes that in and it just shoves it in full-fledged into the GPU buffer that gets transferred over to directly into memory and then transferred over to the GPU for processing. So when they made their additional, sections and stuff, they didn't have to change anything in here. Because they just wrote out the correct size and then it just kind of went and did it. I, on the other hand, don't bring this in. I bring them in as individual things. Right? So what we have here, so prior to the changes, all I was bringing in was vertices here because it's vertex buffers. But now I need to bring in normals, tangents, bitangents, in addition to the texture coordinates. So it was vertices and texture coordinates before. So now I bring all these in and I check them to make sure they're there. If not, I just make an empty array list, or array, I should say. And just for my own clarification, I didn't reuse any variables here. And then I actually pull those in to the data buffers now. I wasn't doing that, and so everything was just wackadoodle. It took me the better part of the day to figure out what was going on. Like I said, I suspected that something was going on with me reading like I wasn't, like the biggest change was reading in new data from the, or writing new data to the JSON files and stuff. But once I finally put two and two together and got this in there, now when I run, hopefully, there we go. So we've got the scene that we had before. You will notice that the lighting is changing every half second. That's because I was having problems. So the way the book did it was they mapped, there's a directional light and there's a point light. The point light is that little green thing you see on the screen here, which I'm moving around with the keys. You can see that you know, it shines and all that stuff. So it's working pretty well. This is the cube model that we were using previously, except it doesn't have any texture. It's just a light now. So that's working relatively well. However, they also mapped to the left arrow and to the right arrow the ability to change a directional light, which is basically, if you think like an overhead, like almost like sunlight kind of thing. You can see it's switching around here. And I do have that mapped to the left and right, but the problem is, as I hold down the button here, it goes way too fast. So I wasn't noticing it happening. So I thought for the longest time it was broken. So I have, what's going on here is every half second I have a loop, like I have, when we go through the game loop, I have it actually change its position from 0 to 360 degrees and then back to 0 again. That's the jump back to 0 that you're seeing there. So that way I could better see that it was actually working, because I was trying to figure out why this wasn't working. And it was. It's just very, very subtle. A little bit more subtle. I don't know why it's a little bit more subtle for me than it was for the books implementation, but it could be just, you know, it could be any number of things. The books implementation relies entirely on you pressing the left and right keys, and you know, with that working too well for mine, maybe that's why it looks more subtle. What I did was I actually dropped the ambient light. So the book drops the ambient light down to like 20%. I dropped it all the way down to 0, which is kind of cool because you can see the green of that light just is the only thing. It's the only light other than the directional light in the scene. And then you can really see the directional light sort of moving around and stuff. So that was really cool. So we've got this working in our own special way, as we tend to do. So you can see that doing its thing. So that was most of the challenges, was just getting all that deferred rendering in place, and getting actually more, the challenge was just getting like the PBR stuff loaded. I'm interested to see like the model that I was using for the OpenGL stuff, that little spaceship model, had what I believe had some PBR stuff in it, potentially, particularly for the thrusters in the back. So I'm kind of interested to see at some point if I can load that up and see how it looks with this. That might be something to do on the side once we get through more of the book here. But that puts us then firmly into chapter 16, which is doing shadow mapping and cascading shadows, or cascaded shadow maps as they call them. A lot of this algorithm is coming from one of the Vulkan, the main Vulkan project examples. So, you know, we'll just follow what's there, basically. But from what I understand, I kind of took a quick peek at the differences. I don't actually have them up, do I? There we go. So the differences between, we're going to do chapter 15 and chapter 16 here. And it looks like, I think there was a bunch of shader changes, but actually it wasn't, as far as things go, the shader changes actually don't seem all that bad. For the lighting shader, the fragment shader, there's some new shadow, 3 new shadow shaders, a geometry shader as well, which I have not seen yet. a vertex and a fragment shader. And these don't look too terrifying, so hopefully we'll be good with that. They also have a new model here, a tree model that they're putting in the middle of the scene, so we'll have our third entity in the scene, which will be nice. They've added some configuration stuff for the size of the shadow maps and whether or not to have debug on for it. Obviously, I'll just kind of hard code these for now until I get a better implementation of what I want for, like, because we got menus now, and I can kind of go in and figure out the menus and have those write to a file and all that stuff. So that'll be something we do. Ignore the logger stuff because I was logging out some stuff from the book's code so that I could compare numbers between what the book was getting and what I was getting, which helped me figure out the buffer sizes for the models, for the materials that the book code was generating were significantly larger than the ones I was generating, and that put me on the path of like, oh yeah, I didn't add, all the tangents and everything else in there. So that's what I did for that little debugging. We have a new shadow renderer that we'll add to the ever-growing list of renderers that take over various parts of the pipeline here. And then I think there's a lot of let's see, there's changes to the light render here, which just to create the shadow buffers, I think. And then there's a brand new class. Again, it's relatively short and sweet. And then the rest of these, I think, most of these are just adding an additional parameter to attachment. So we must be adding a parameter to attachment along the way. And these are just adding that in. So we'll do a lot of little changes there. We also moved the cleanup of the fragment storage up, so that's a thing. And then again, ignore those. Is that scene render? I think we were just looking at that. Cascade data is brand new. Cascade shadow is brand new. Shadow render is a brand new renderer. This is going to take the most amount of time. This is the big end here. Because there's a lot. I mean, it's an entire render again, and a lot of it is the same code that exists in other renders, but slightly different. So that's something I definitely want to come back and try to refactor and see if there's a better way there. And then there's a whole utility class here with an algorithm from the Vulkan examples. So that'll be this will be kind of fun to implement in Java rather than in the shader code. And bits and pieces here. There's also more features being added or being turned on. Support features for depth and stuff like that. So we'll have to tackle that. Adding a layer count to the image view. Pipeline now has depth clamp enable. Build in for the same thing. Texture doesn't have actually any changes. It's just I have a logger in there. Seeing the shadow map count is added as a static, and then I think that's it. Everything else is the shaders and the new model. So I think we can get a decent amount of this done. Probably won't get it all done. Most likely won't get it all done tonight, but we can get a decent amount, I think. So let's start with actually no changes in models cache at all, so that's good. Can't start in render because we need the shadow render class. So let's just skip that for a moment. I think we're gonna have to start in the shadow package here, which is all new stuff, and this is probably the bulk of the changes anyway. So let's just jump on in then. So we got cascade data is what we're starting with. Right, let me get this down to the bottom here. Let's do close all tabs, and we'll close all tabs here. We'll make this top path, and let me switch this over to chapter 16. There we go. Okay, so I'm gonna do what's the name of it? Cascade data. Oh, is that a? That's fine. We'll just do that. Wait, that's Cascade Shadows. Cascade Data. Here we go. This is basically just a it's not really a record because it's doing something different here. It's mostly a record. But because this is doing something different, I'm gonna make it a regular class just so it stands out more. So let's do. So this is in shadow stuff, right? Let's make a new package. Say cascade data, and we do on private final matrix for F. View matrix and private float with distance. Wait. Oh, really? That's all you're doing there? Yeah, leave that then. Just that up here. Alright, and just have getters and setters basically, but set they do have a set Session view matrix. Yeah. Okay. Set split distance. Split distance. Matrix. Okay. Set session view matrix. Go. Very good. Alright, well that was easy peasy. I guess Cascade Shadows is the next one. And this is just... It just has the Cascade data, a list of Cascade data in it. Okay. Alright. Data, and I'm doing new array lists. Okay. What are they doing here? They're saying, I've seen shadow map cascade counts. Okay, 4 is less than. So this would be both insane. This is, I think, the only change to scene here. So public static final ints. Okay, and this plus. Alright, and then I just have a getter here. Cool. That's basically 3 files down at that point. I think that was the only change to scene, right? If I can find it. Yeah, shadow map cascade count. Yeah, that was the only change of scene. Alright, so that's 3. That is 3 files down. Alright, so next one. Get shadow utils. Let's do the shadow utils first because I have a feeling shadow render will probably make use of it. So we'll do shadow utils. Helps to spell it correctly. Shadow utils. I'll put a logger in here just in case I need it. We got private, static, final, floats, lambda, 0.95f, private, static, final, vector 3f, up, vector 3f, 0f, 1f, 0f, 1f, 0f. Alright. Static final. Up. Alt. 001. Okay. Making it a utility class. So it should have private constructor, so you can't call it that way. All right, I am going to do one copy here. I'm going to copy this comment because it's got its attribution number 1 and number 2. It's got the URLs and stuff in it. I don't feel like typing those out. So sue me there on that one. I don't think anybody will be upset with me copying it because it's got URLs in it. But I don't want to get wrong. Public static void updates cascade shadows. Okay. So you get the camera, the view matrix, projection matrix. Okay. Camera, get the matrix out of there. Projection. Pulling stuff pulling objects out of the scene so we can work on them. Projection matrix. It's projection, get projection matrix. List, light. Lights equals C, get lights. For each light, they did this. See, now I know this is like some of these later chapters. I can really tell that they just boldface copied from whatever C source they were looking at, because they don't even attempt to Java-ify things here. For instance, this for loop. Yes, this works. It is a traditional for loop. It is not necessary to do this way at all. And honestly, they're just looking for the light they're looking for the directional light. So I could do a for each here and do that same thing, or I can just use the Java streams to pull out the directional light, which is what I'm going to do. And they don't even need, so light, directional lights. Is lights used again? It is not. All right. So we'll make this even terser. So I want light, directional light. Scene, get lights, stream. Filter. actually, I could just do light directional. Find first. Yeah, it's literally just finding the first one I can find. Find first. Or else, no. Right, and that basically does this whole thing. Does exactly what this does. Yeah, it's a lot more compact. Alright. And we can just say if directional light is null. New runtime exception. Not find light source. Let's see. There we go. Very good. And then doing light position. Go. Float. Now I'm going to just do a regular float array here because I have a feeling we're getting into the algorithm proper. Cascade splits. Float. Okay. Although, honestly, what are they using that for? Float P is I plus 1. Do I have a float? Ratio, uniform. Huh. Okay. Yeah, I'll leave that as an array then, because it'll be. It looks like it'll be easier to deal with. Getting viewing frustrums. Okay, interesting. All right. I wanted to see how that was being used and if I could change it, if changing it would make it better, but no, it looks like it's more terse, I guess this way. Projection, get Z near, float far, clip is projection, get Z far. Okay, float range is clip minus near clip. Whoop. Okay. Minimum Z is near clip and max Z is near let's clip range. Maximum Z minus min Z is the range, and the ratio Max Z divided by min Z. Okay. All right, and then we've got. So what are they doing with Cascade data list? Are they using that again, or they just literally just did to get the number of cascades? Oh, they're using it to, okay. They're storing it back in there, which makes sense. Although, is this inside of a loop? Yeah, it is. Okay. Alright, fine. Cascade data. Size. Alright. So I'm going to copy this. So we have proper attribution. Alright, so for int I is 0, I is less than the number of cascades, I plus plus. P is I plus 1 divided by float of that, which isn't that? No, it's not a float, it's an integer, right? Yeah, it's an integer. Okay. And then log is convert to float of minimum z times at the pal ratio to p. And then float uniform. Oops. NZ plus range times P. D is lambda times log minus uniform plus uniform. And cascade splits I equals D minus near clip divided by clip range. Okay. And that's the end of that for loop. Calculate orthographic projection matrix for each shadow cascade. Okay. What are we doing here? Last split distance. Yeah. I is 0, I less than the number of cascades, I plus plus. Cascade splits I. Vector 3F. Viewing frustum corners. Oops. What are we doing here? Vector 4F. J is less than 8. J is 0, J is less than 8, J plus plus. I'm looping over this thing they just created. Why is this? So they're updating. Okay, I'm like, why is this here if it's just got static numbers in it, but it doesn't have static numbers because they've got this. So every time through this outer loop, they're going to reset this. Okay. And then in here, in the inner loop, they're going to set each individual one to this calculation. So to the original value with 1.0 as the additional vector multiplied by inverse camera. So projection matrix multiplied by view matrix inverted. Okay. So wait. Oh, doing another loop down here. J plus 4 subtracted by that corner. I'm trying to process some of this because it's what's the word I'm looking for? It's got here's my issue here. It's not really an issue. It's something that just pops out at me. We've set up all these vectors to be the same values. This is their initial values. This time through the loop, we're going to calculate this, which is the projection matrix times the view matrix, and invert it. All right, the projection matrix times the view matrix are always going to be the exact same value, because we're not updating them, right? Yeah, so the projection matrix and the view matrix never get updated. So this value is always going to be the same, yet we're calculating it every time through the loop, which is weird. It's always going to be the same. Like, we're basically, I mean, number of cascades is set to 3, right? So we're going to calculate the same value 3 freaking times over and over again, for whatever reason. And we're going to populate this corner. We're going to calculate this corner based on that thing. First from corners J. So this is always going to evaluate to whatever vectors here times the inverse cam. So when we're setting this up, why wouldn't we calculate this outside the loop and then set all of these to, instead of vector 3f's, just set them all to frickin' this, because this never changes, right? Because all they're doing here is and then they're bringing it back down to a vector 3f for some reason, because they have to set it back in here. So they temporarily made it a 4 vector with the w set to 1 to multiply it, which, okay, that's fine. It obviously affects the value, but then they're dividing by the w. Okay, I just noticed that. So they're setting it to this divided by the w parameter there. But again, I submit, why the F are you doing that 3 times when you're going to get the same exact value every freaking time up to this point? Like, literally, you're getting the same exact value up to this point. So you could just do it once, you know, outside the loop, and then inside the loop, just, I guess, I mean, you'd have to do a copy, which could be a pain in the ass. I mean, I get it. It's only going through the loop 3 times. It's not a big deal, but I still, this pisses me off. Like, I see obvious, like, idiocy here, and it's just, it bothers me. And down here, let's cascade splits I. Split this. Now these are based on what are based on the loop. So this makes sense to be inside the loop. Yeah, that makes sense to be inside the loop. From center is 0. And we're adding all the corners to it, so that makes sense to be inside the loop. And we're dividing by 8. Yeah, because you're adding up. Okay, and you're dividing by 8 to get the center. Okay. All right, let me think about this for a second. I have to take a biology break. I will be right back. Enjoy the music, please. I'm back. Sorry for the extended break there. Okay. So, one thing I want to do here. I know this ultimately probably doesn't amount to a whole lot, but it just makes me feel better. Because there might come a time when I want to, like, crank up the number of cascading shadows, and I don't want this thing to be slow. So I want to check something first. So vector 3F, does this implement clonable? It does. So it's clonable. Okay, so then arrays copy of. So I think this uses clone, right? We'll do copy of object. Copies a specified array, truncating or padding with nulls to cut so the copy has a specified length. For all indices that are valid in both the original array and the copy, the two arrays will contain identical values. For any indices that are valid in the copy, not in the original copy, will contain nulls. Such indices will exist. The resulting array is of exactly the same class as the original array. But I want just is there a copy of that doesn't have an int? I guess they all take one. The thing is, let me see, can I get TMT copy of original? What does it actually do? New type, object class, object new length. Otherwise, array, new instance, new type, component type, new length. System array copy. Array copy. Copies an array from the specified source array beginning at the specified position. Okay. Yeah, effectively, sure. Intrinsic candidate. I can't see the implementation of this. What I want to know is if it will do, if it will call clone. I suspect it calls clone when it tries to make the copy of the array. Let me see what the internet has to say on it. Java arrays dot copy of clone. Does Java arrays copy of use clone on objects in array? Like copies, well, according to this, it only copies of references. Dot clone or arrays copy of. More time than clone. It provides the same shallow copy of data. Yeah. So it's not what I want. I want to. So I guess I got to do a deep copy on it, which we have array utils. Deep copy. Copy. Is that what it's called? Yeah, it's copying from one to the other. Is there Apache Commons deep copy? Serialization utils. I thought they had something. Deep clone an object using serialization. Oh, but it does it by it does it by serializing the object out, and then yeah, that's that's gonna take that's way longer than just. But I mean, it's got clone, like it's clonable, so I should be able to. I mean, I'd have to loop over it and clone it. Each time. I don't know, it just bothers me. It bothers me that this is like this. With values that don't change. Really bothers me. it really bothers me that that's like that. Of course, everything I do is probably going to make it worse as far as performance goes. I don't know. I know I'm spending a lot of time on something that could be done in 20 seconds here, but it's just... I see stuff like this and it just bothers me. I know it doesn't amount to a whole lot. We're talking probably nanoseconds, but it's just... I wonder if... What's the ultimate? The ultimate is to have these like initial transformed corners, or world space corners. Because the other thing that bothers me here too is, so we got the projection matrix and we got the view matrix here. And if I'm not mistaken, so it's brought in up there. And I don't see it highlighted anywhere else. Yeah, I don't see it highlighted anywhere else. So that's the other part of this that bothers me, is to have basically both of these variables pulled in at the very top of the method, and they're used literally once in the method, right? Which is not, like, first of all, why even pull them out as variables? Just use them directly. Although I guess in this particular case, yeah, you would have to do scene, projection, get projection matrix, but you know, it makes sense, I guess, from that perspective. The view matrix, you can just do camera, get view matrix. Projection is used elsewhere, so you know, these don't need to be that way. And then that way it signals to you that this is only being used probably once, because you didn't bother to make a variable out of it. When you bother to make a variable out of something, usually you're going to use it more than once. Almost always. It's not just a way of saving typing. You know, these are kinds of things that I, just over the years of working on code, these are the styles, assumptions, bad assumptions maybe, that often you come across when you come into new code, is you're like, all right, assuming others are following a similar style to me, you know, they're not going to create a variable that's used only once. They sometimes do, but more often than not, they're just going to do it and then, you know. And I try to go through my code and make sure I don't do stuff like this whenever I can. I mean, I don't always. Sometimes you just don't have the time, but you know, when you're like, you write the code and then you come back and you write it again or refactor it again, you know, that's one of the things you do. It's kind of tighten things up there a little bit, because a lot of times what'll happen is you'll make a variable because you'll think you'll need it a couple different times, And then you'll get all the way to the end and realize, oh no, I didn't actually need that. And then I just go back and, try to tighten up a little bit. Just to make things a little more explicit to the next person who's reading the code, or to myself reading the code months from now. So I know, oh, if I didn't bother to make a variable out of it, then it's probably used only in this one spot. The other thing is too, like this stuff goes together, right? As like initialization for the loop. Really, initialization outside the loop. And then this has stuff that depends on things that are calculated in the loop. Distance, split distance. Although I guess it's not really necessarily calculated here. It's still based on a loop. It's a variable that we're looping over. So my point here is by pulling this out, at least into another method, even if I leave it inside the loop, which I'm not going to leave it inside the loop, but even if I were to, just pulling it out into its own private method would at least be a good signal to be like, hey, this thing is always going to give you, would be a clue that it's going to give you just the same value every time through, because then you can give the method a name like set initial value or set initial world frustrum, and then you're not beholden to that name. Then you can come in here and just still call it frustrum corners, which will be based on all this stuff. It's just the method tells you, hey, this is a one shot, or this is always going to give you the same value back for the 3 loops, or however many loops you're doing. Yeah. How am I going to do this? Because the tricky part here is it's a list. Well, really an array, but even if it was a list, it would still be tricky. So I really want, I feel like the only way I'm going to do this without it getting out of control is to just call the method inside the loop, which I really don't want to do. I mean, if I put it, I can put the, I can make the method go through and clone. Oh, no, I can't really. I can't really do that. So I'm going to still have an ugly... Is that true? I mean, I'll still have an ugly initialization. Vector, I think it takes a... Yeah, it takes like a different... It doesn't take another vector 3F, it takes a different thing there. Let's see something here. Clone. Clone not supported. Is it really? Oh, okay. Well, cloning is not even supported, even though it implements clonable. Okay. Okay. Still not terrible. Fuck it, I'm gonna do it. Let's make a private static final button. No. Private static vector 3F array init first room to world wards and need what? The matrix 4F projection matrix and so matrix 4F view matrix. Okay. So we do oops. We got new vector 3F negative 1F 1F 0F. One, one, and 0F. That is 1F negative, oops, negative 1F 0. That's 1F 1F 1 or 0F. Right, it's 1, 2, 3, 4. 1, 2, 3, 4. Negative 1, 0. So it's 1, negative 1, 0, 2, 4. And then it's negative 1, 1, 1. 1, 1, 1. It's 1, 1, 1. And then 1, negative 1, 1. Negative 1, negative 1, 1. Okay. That's 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. Negative 1, 1, 0. Negative 1, 1, 0. 1, 1, 0. 1, 1, 0. 1, negative 1, 0. 1, negative 1, 0. Negative 1, negative 1, 0. Negative 1, negative 1, 0. Negative 1, positive 1, positive 1. Positive 1, positive 1. 1, 1, 1. 1, 1, 1. 1, negative 1, 1. 1, negative 1, 1. Negative 1, negative 1. I think I got it. I think I got it. All right. Matrix 4F. Projection matrix dot multiply view matrix invert. Okay. And then for int I is 0, I is less than 8. I is less than there's length. I plus plus. Then vector 4f inverse corner vector 4f corners I 1.0 f times inverse camera there, and then corners I is new vector 3f inverse corner x, inverse corner y, inverse corner z, divided by inverse corner w. Okay. That sets all of that up, and then we just return corners. Right, and then before the loop, I'm going to do vector df array initial viewing. Oh, just say viewing frustum corners is frustum to world coordinates, and we want projection matrix, which is just this. And matrix. There we go. Now it does mean down here I'm going to have to do what's the best way to do this? There's no best way to do this. Let's just do vector 3f. No. No, this, I need to change this to something else. There we go. That's a little bit better. This will equal new vector 3f initial viewing frustum corners length. Zero. Oops, not I. J is 0. J less than. Frustum corners length plus this new vector 3f J dot X Y Z. Yeah, that ended up being more of a mess than it probably was worth. It's probably a hell of a lot slower now, but oh well. Sometimes you win some, sometimes you lose some. And I definitely felt like I lost that one. Alright, so then for int j equals 0, j is less than 4, j is plus. Distance is new vector 3f. Viewing frustum corners j plus 4. Subtract it from frustum corners j. J plus 4 equals new do 3f and corners j plus new vector 3f distance. Wait, you can't take a... Should I be able to just do this here? Yeah, I thought they took another. That says vector 3FC. I guess that's an interface or something. Okay, that's what threw me off. All right, so it does. I mean, yeah, sure. Anyway, distance dot multiply by split distance. Okay. J is new vector 3f where's J and new vector 3f distance by last split distance. Okay. The center of it. J equals 0, J less than corners length, J plus plus, from center add corners J. And then center divide float corners dot length. Go. Trying to eliminate magic numbers wherever I can. Or up, floats, here, radius, 0f, and for it's j equals 0, js, plus then corners length, j plus plus, distance equals new vector 3f. Corners j minus the center length. What the hell is length doing? Turn the length of this vector. Okay. Well, oh, it's vector 3f, so no, it's x, y, z. Okay. Whatever. Sphere radius equals math max sphere radius and distance. Sphere radius equals float math dot ceiling sphere radius times 16f divided by 16f. Alright. Max extents sphere radius for all the vector points there. Our min extents max extents multiplied by -1. So we're nullifying it. Okay. Or negating it, nullifying it. Actually, wouldn't it be faster just do negate? Instead of multiplying by -1? Or does that not negate everything? Negate this vector. Does that not negate all the different parts of the vector? Yeah, it does. X becomes negative x, y becomes negative y, z becomes negative z. Yeah. That would be probably faster than doing a multiply operation. And right direction. It's new vector 3f. Light position. Just give it a light position, right? X, Y, and I'll just put X, Y, and Z in there. The same, yeah, create a new vector 3f with the same values as Z. Yeah, okay, that saves me a little bit of typing. get position of the shadow camera. New vector 3F. Center. And light direction multiplied by the min extents z. What happens when you give... Oh, no, it's just... Race is afloat. Okay, that's fine. Never mind. Alright, and then the dot products. Dot absolute value, new vector 3F of light position dot product of up. If dot is 1F, up equals up alt. Var light new matrix 4F. Okay. Look at shadow camera position first from center and up. Var light orthographic tricks matrix 4F ortho so min extents x max extents x min extents y max extents y 0 for the near max extents z minus min extents z, and I guess 0 to 1 is probably true, right? It's true. Okay. Stabilize shadow map size is get the shadow map size. So let me put that here for now. So to public static, static final int shadow map size. I think it was 2048 in their thing, right? Is our engine config? Shadow map size is 2048. So 2K. Oof. It'd be really great if I could spell today. So shadow map size is shadow map size vector 4F shadow origin vector 4F 0 0 0 light U matrix transform it by shadow origin, so basically rotating it around the origin, I believe, the shadow origin, I believe. And shadow origin multiply by shadow map size divided by 2. Rounded origin shadow origin dot round. The hell does dot round do? Round it mathematically. Set each component of this vector to the closest float that is equal to a mathematical integer with ties rounding to positive infinity. In other words, it's rounding up or down, or half round as they call it, to get a whole number out of a decimal. Okay. I'll tell you what, as bad as I am at math, there are at least some things that stuck with me. Like algebra is still a thing I can do with some kind of success. I mean, I'm certainly not great at it, but I could certainly navigate it. And linear algebra, which is all this matrix stuff, so you see like things I'm doing like matrix 4F and all that stuff, and dot products and stuff like that. I actually did really, really well with that in college. There's something about matrices when you lay them out on a piece of paper and you do matrix multiplication and stuff like that by hand, where it just kind of, I don't think I could do it by hand anymore. I'd have to look up, I have my old college textbooks, I kept them for that because I liked linear algebra a lot, honestly. So I kept my textbook for it. But if I were to go back and reread it a little bit, I could probably do matrix multiplications and dot products and stuff on a piece of paper again. Those, for some reason, those always, I didn't really have any problems with those. Those kind of clicked with me right away. I guess because they almost feel like programming on paper, I guess. I just kind of gravitated towards that. Now, I'm sure as we do more stuff with this engine, that we're probably going to run across some calculus, and that's where I'm going to be really struggling, because I did not do well with calculus at all. So I'm hoping some kind souls out there have already derived the algebra for a lot of the stuff that we'll need, because I can deal with algebra. I can't really deal with calculus too much. Although it is interesting that calculus is really, like, if you do the calculus, you can. I never quite figured out how that works, but apparently, if you do the calculus on things, that will enable you to derive the algebraic formula that also gets you the correct answer. I'm not sure how that's ever. I don't think I've ever seen anyone actually derive an algebraic formula from a calculus thing before. That would be kind of fascinating to watch. I don't know how exactly that works. I just know from my limited understanding, that's how they do it. Because my understanding from that comes from physics, because they made us do, for whatever reason, they made us take physics 1 and physics 2 in college. They made all the computer science people take it as part of the curriculum. And my physics 1 teacher freaking loved calculus. Like, everything was, you want to calculate the velocity, it's the derivative of this and double derivative of that and all this stuff. And that was a nightmare. And I got to physics 2, and I'm like, oh man, I don't know how I'm going to do this, because I have to take it, and I don't know how the frick I'm going to get through it. And our physics 2 teacher was like, all right, here's the algebra to do all these things. Just use that. And I was like, oh, we're not doing like the calculus and stuff. He's like, no, nobody uses calculus for that. And he says, and he was also, all of his tests, all of his exams and his tests were open book. So you could use your textbook, you could use your notes. I was like, oh, this is refreshing. And he's like, yeah, in the real world, if you're doing physics problems, you're going to have textbooks, you're going to have the internet, you're going to have whatever. It's like, you still got to solve the problem, right? I mean, you still got to use the right formula. You still got to find the right, the right thing to do and the right way to solve it. So it's like, what do I care if you use your textbook or your notes? It's like that's just how it works in real life. He was a cool dude. He was a cool dude. He was an older dude, but he was a cool dude. He seemed like he had seen some shit. like he was a dude that actually probably worked on some stuff and was just like, he was probably turned to teaching just as like a retirement vehicle. Like, we always joke in technology that there will come a time when we just can't do the code anymore, so we'll just take a cushy job retiring we'll take a cushy job as a database administrator for the last couple of years before retirement. That's like the retirement grease. I imagine professorship is probably something similar for like physics guys who are just like, you know what? I've worked at a lot of stuff. I've made my money. I just want to relax for the next couple of years until retirement, and I'll just teach. And he just kind of had that air about him. I don't know if that was true or not, but he just had sort of that walk, as it were. He was a cool dude. Very practical dude, which was very refreshing, because so many professors are pie in the sky, theoretical stuff, And when you get one who's just like, here's a grounded explanation of things. Here's how things work in real life instead of in a textbook. And here's how this, here's how you do this. Here's how you do that. In the real world, it's very refreshing sometimes. I mean, yes, the theory and all that stuff is you have to know it. You have to understand it. But one of the biggest flaws when I was going through college was they pumped us full of theory, but no practical skills. And luckily for me, and for a few others, we were already building up practical skills on our own, doing our own things. Because without that, it would have been, it was pretty hard as it was getting into the job market, or getting into starting the career, getting out into the real world, because I had very little experience with like source control and just basic stuff. I'd never seen Jira prior to that, trouble tickets and all this stuff. And that's like, those are practical skills that apply across the board that they just never bothered with. And it was really annoying because you pay, I didn't pay nearly as much as people pay now for college, but like, it was still a significant amount, I think when I finished, I think it was up to like something like 42 grand or something a year for tuition, which I know is nothing compared to what it is today. But when you consider that when I started there 4 years prior, it was like half that. And my scholarship was only a partial scholarship. It was only like, I want to say, I think initially it was like half of, I want to say it was like 20, no, it's like $15,000 or $18,000, I think was my scholarship, because I went in on a academic scholarship, which even back then didn't amount to a whole lot you would think it would amount to. Like, you would think they would give out more academic scholarships because they're an academic organization and that's supposed to be an important thing. But no, really, it was, if you played a sport, in particular basketball, for that particular college, you got a full ride. Didn't matter how much of a dumbass you are, you didn't have to pay any bills. That was a real kick in the crotch. I'll tell you that. I was salty about that for a very, very long time. Very, very long time. But the more things change, the more they stay the same. Round offset. Origin, so shadow origin. But I think I've mentioned it before that I absolutely had to graduate in 4 years. Like, I didn't have a choice. I couldn't afford even a half a year more because the tuition had like the tuition had jumped, basically doubled over the time that I was there, and the scholarship didn't change at all. And I actually, for the financial aid, like I had Stafford loan and stuff like that, financial aid only covered so much. Like it would not, like I think financial aid was like $5,000 was the max I could get per semester. Per semester? Yeah, I think it was per semester, 5,000 to 10,000 a year. Which at first covered everything, but then towards the end there, it wasn't covering enough, and I was making up the difference. I was paying the tuition that wasn't covered by all that stuff out of pocket, plus all the out of pocket for books and supplies and all that nonsense. And bearing in mind that while Amazon was mostly a bookstore back then, it was not nearly as popular as it is today, so it was largely still unknown. largely still unknown. In fact, I'm pretty sure Amazon was there. I'm curious now. When was Amazon? Yeah, 1994, which is when I started my freshman year. No, sorry. 1994 was when I started my freshman year of high school, not of college. So I started college in 98. So yeah, it was still relatively I think I remember people saying, "Oh, we're getting our books on Amazon," kind of thing. I remember them shopping themselves around to colleges at the time because that was a big thing. Books cost a ton of money, like hundreds of dollars for textbooks, just for one textbook, and you usually had to have multiples. And Amazon was like, "Hey, you guys need textbooks? We can get them to you for on the cheap." And so I remember them advertising themselves a lot. I don't think I bought any textbooks on there at the time. Probably should have, but like it wasn't really a big. It hadn't really been that established yet. Even by the time I got out of college, which would have been 2002, it was still kind of it was known, but it wasn't like the big multinational that it was now, as far as I remember. But then again, we went through like the .com bust and all that stuff at that time too, so it was kind of hard to get any kind of information about any companies because everybody was like, everything was exploding all over the place. And the internet was a shadow of its current self. So, lights, orthographic matrix, M30. M30. Light orthographic matrix, that M30 plus round offset X. What the hell is M30? Oh. Set the value of the matrix element at column 3 and row 0. Got it. Okay. I'm like, what the hell? Why is there a method called M30? Now it makes sense. All right. 31. Lights. Matrix M31 plus round offsets Y. Two, 3, 2, and 30. Oops, 3. Let's be Z, W. Store, split distance, matrix, and cascade. So okay, cascade data. I set split distance to near clip plus split distance times clip range times -1. I'll tell you, there's one thing that, this is a weird thing to bother me, but it's a thing that does bother me whenever I see this a lot in, not just in this code, but I've looked at code in other game engines and stuff that are out there, or other games that are out there. I like parentheses when I do mathematical operations. And I know the order of operations, and I can go look up the order of operations and see, that, in this particular case, you see plus and a multiply and all that stuff, and that's going to work a certain way, PEMDAS and all that stuff. I get it. But what I don't like about something like this is it's very easy to misread what's going on with the math when you haven't had your cup of coffee yet, or something like that, or it's late at night or something like that. So I always, even though, yes, the multiplication is going to happen first and all that stuff, I get it, I would still put normally parentheses around split disk times clip range. Not because it's necessary, but because when you're reading the code, it's a lot easier to see, oh, okay, that's this is the intent. This is the intent, is for this to go this way. But I see it a lot. I see it a ton in the shaders that we've done here and stuff like that. It's just, so I get it. I get that it's a hang up that I have that nobody else has, but it's just something that I do just because, like, after a while, reading code can turn into like reading a spreadsheet, right? Like, at some point, everything, all the numbers and stuff start to just kind of blend together, and you misread it, or you end up going down a blind alley thinking that something's wrong when it's perfectly fine. You know what I mean? And so I do these little things that they take a little extra time, but I do these little things because it just helps when you're in a state of programmer delirium. And, you know what I mean? It just helps to, like, navigate. You're like, okay, I get it. I'm not being, I'm not losing my mind just yet, kind of thing, Oh man. All right, and find my light view matrix. Okay, last split distance equals cascade splits I. Okay. And that is a loop and the function. We'll see if my alterations end up causing problems or if they just work. Local variable min z is redundant. Yeah, it kind of is, because it's only used down here, right? Oh, it's used down here too. Yeah, I mean, they're basically saying it's set to a copy of it's point. Yeah, it's set to a copy of near clip. And then it's never. It's just read only basically. But yeah, it's fine. It makes sense to have that there. Okay. Cool. Alright, so that was the utility. It took a little bit, but that was mostly because I was trying to I was doing my usual, should I do it this way or should I do it a different way? And then shadow render is a whole big render class here to do. But I think, my friends, so I'm going to do this probably off camera. And probably finish tomorrow. I'm going to probably do this off camera tomorrow. I'll probably finish up the rest of this chapter because I think the rest of this, I mean, shadow render is a big class to go through, and I've already gone through a couple of these, so I can kind of do this faster just with some music playing and just not worrying about being mildly entertaining. And the rest are just kind of small changes. Gotta copy the tree over and stuff like that. But yeah, let's just, out of curiosity, let's run the books version here and see what it looks like. There it is. There's their tree, and there's all the cascading shadows coming off the tree leaves. And now, actually, we have shadows down here now too from these poles, which is kind of nice. So that's cool. So this is what we're angling for, basically. Very nice indeed. All right, so that's what the book does. So now we know what we're looking for. So I'll just have to get on that. Hopefully I'll have that done probably tomorrow. I don't know if I'm gonna. I don't know what the streaming is gonna be like this week, because I'm definitely gonna stream on a normal schedule, but I don't know if I'm gonna play games or if I'm going to do more coding. I'm kind of I'm on a kick right now where I'm just like, stuff's getting done and it's kind of cool and awesome, and I'm just kind of I'm motivated to like write some code. Like tonight I was intending on just playing a game. I was going to like fire up Dragon Quest 2, but I was like, you know what, honestly, don't feel like it right now. I just want to do some code, which is a weird thing to say, but it's just kind of you know, there's sometimes you just get into that, like stuff is progressing and it's getting exciting because you're starting to see, like we spent so much time here without being able to really see the changes as they're happening. And now that I've got like the basic fundamentals in for the most part, now the changes are starting to reflect more like visually and stuff, which is kind of nice. So yeah, that's, and also, I mean, once we get through the remaining chapters here, so we're on chapter 16 now, and so that means basically, and I'll probably have 16 done tomorrow off camera. So that gives us 17, which is animations, which I imagine is going to be a real biatch, but it's going to be even more. So we have to add in reading in the animation nodes and stuff from the files. So that's going to, I just have to make sure. See, I want to do this soon so that I remember that I need to add them in on the other side, on the vectors and stuff. Vertices, I should say. So that's a thing. And then using a compute shader and stuff like that. So there's a lot in this, in chapter 17. This feels like something that I could just do off camera and just like run through boldface, because there's probably a lot of like brand new classes here probably. There's obviously updates to like the scene rendering and stuff, but yeah, shadow rendering and things like that. But yeah, so that might be something. But then we'll have instead of a tree in the middle of the courtyard, we'll have a dude with a lantern. So that'll be kind of cool. And what else? 18 is buffer device addressing. I'm guessing this doesn't actually change anything visually. No. This doesn't. Chapter 18 doesn't change anything visually, so it would behoove me to just kind of get that, just knock that out. It's just the way it refers to, the way shaders refer to descriptor sets and stuff. And 19 is indirect drawing, which is more efficient, apparently. But I'm imagining that this isn't really going to, again, this is going to be like background changes and not something visual. Other than, you know, it might load even faster than it loads now, which would be nice. And then 20 is multi-threading. Again, that's more of a back-end stuff. And this actually looks like it's going to be relatively straightforward. It looks like, doesn't look like there's a whole lot there. And 21 is not done, which is ray tracing. So then we're pretty well done there. There is, like I said, an appendix that I want to go through about like making sure I can troubleshoot things, like add in code to do troubleshooting. And Appendix 2 just goes over, like, they create a simple game here, which is kind of cool. So I won't be doing any of that, but it's cool that it's there at least. And there was, I did see something, it must be in the OpenGL book, but I swore I saw another appendix flown around. That had something to do with like shader debugging, maybe. Maybe not. I don't know. Anyway, my friends, that's where we're at. We're up to chapter 16. We're making our way through so we can get all the shadows that we can get on the way. But yeah, like I said, I don't know if I'm going to do more coding streams this week, or if I'm going to go back doing some games, whatever games I'm in the mood for. I don't know yet. I'm going to just play it by ear. I'm enjoying that. I enjoy that I have something that I can kind of look at and play around with and tweak, and more importantly, I enjoy that I can now kind of see the bigger picture. Well, not the bigger picture, but I can see the code, and I've worked enough with the code now that I can kind of start seeing. There's things in my head where I'm like, I want to redo, or I want to refactor this. I want to refactor that. I want to move this around. I want to move that around. I want to get this out of here, and I want, so I'm seeing a lot of stuff there. So there's going to be definitely some streams where I'm just going through and just like refactoring things, just to satisfy that portion of my brain. But yeah, that's where we're at. That's where we're at right now. Thanks so much, everyone, for watching. If you happen to run across this on the YouTubes and you have a like and or a subscribe that you can toss my way, that would be really swell and awesome. It helps out tremendously, and I appreciate it greatly. Otherwise, thank you so much, everyone, for watching. I hope everyone has an excellent morning, afternoon, or evening, depending on what it is for you. And hope to see you back here again in the future for some more stuff, whatever happens to suit your fancy. Until then, see you later.